want to move on to obsolescence risk management now. Now, Tim explained earlier that Diamond OM sort of covers a lot of that from a digital software perspective for management of it. But can we talk about basic risk management? Could we talk a little bit about likelihood versus impact, please, of parts, items, anything like that? How is that measured from a sort of a manual perspective, I suppose?
Likelihood is the first phase of the obsolescence management assessment process. And what we're talking about is likelihood of an item going obsolete sometime or becoming obsolescent sometime in the future. And it's based in terms of IEC 62402 2019 on having a year's to end of production forecast, which you can obtain by any number of reasons, data mining, using third-party tools and so forth. The number of suppliers or manufacturers of that particular item, and the more manufacturers of that item there is, then your risk diminishes. And then thirdly is availability of the item to procure, and that forms up what they call the likelihood. To me, and availability in this term is actually what we call procurability. It means you can buy from that particular source. In webs, we actually bring in a fourth one. We bring in availability. So we know we can buy that item from another source, legitimate source, that the client or the customer cannot buy from. And I'd take no-take stock numbering, for example, like that, where you have a list of manufacturers, equipment you can buy, and you can buy from them. That's what I call procurability. But there are other sources of supply that are legitimate on the marketplace that you can go and buy from. And this goes into a traffic light system of red, amber, green that gives you either a green, which is a low risk of likelihood of going obsolete. Medium is somewhere between, maybe you have 2 suppliers or something like that rather than 1 or 4. And then green is where you've got all the way through that. You've got a good source of supply, you've got a good years to end of production forecast, and a good procurability of capability. The big problem with that, in that approach, is that many companies take a single source solution. So they buy just single source, and they've got a good contracts to do that. So what we've built into the Diamond tool is an ability to take that away from being a high risk into a medium or low risk. And the same applies for software, of course, because normally software, especially you take Windows, you just have one developer. So that could classify as just one source of supply, which give you a high risk. I mean, in fact, that is not the true case. So that's likelihood of an obsolescence item. Likelihood of an item having an obsolescence impact on you sometime in the future. Impact is where we actually take the likelihood and assess it against our particular program. It's what we call the so what factor. So if you've got something that's going to have an impact on your obsolescence on your program, you can very simply, for example, and it's a very simple example, look at the stock you've got. And if the stock you have against the consumption rates that you've got predicted go beyond the life of what your program is, then that is then a resolution that's available. Then there are other impact assessments you can start looking at. You can start looking at criticality. You can start looking at repair. Can you repair the items? Can you start looking at rising rates to see what the issues are? There's a whole raft of actions that go into the impact assessment. And what we've built into Diamond, we've built in basically like a toggle switch capability where you can switch toggles on to say, I want to have inventory versus consumption rates. I want to have failure information, like from reliability modeling or from a FAMICA type reporting back from of failures, from turnaround times, from MROs. So you can choose a whole raft of those capabilities to produce you a really quite finite impact assessment based on your company. Then once you've got all that information, of course, you're then into looking at saying, I've got a problem with the impact. I do have an impact of this likelihood. Then what is my resolution? What's my approach to the resolutions? The use of criticality. If in terms of impact assessment, the use of criticality is sometimes used by companies to replace any other information they've got. If they haven't got any failure information, no stock, no inventory, they want to know what the criticality of those items are that they've got, so they can then prioritize the impact of view on criticality of item. Now that is at the item level. Then when you actually do the overall picture of what your impact is on your system, you will then start to look at a series of criticalities of where that equipment's operational. And if I take a very simple one of a ship, for example, then mission critical is obviously fairly high. Then with the sort of fight, move, and float is high. But then just some other things can be fairly low in criticality. But that's all part of the assessment you look at of when you want to of assessing the obsolescence management activity. So there's two things: there's criticality of the component, and there's criticality of the equipment stroke platform that it goes into and its operational criticality.
And that criticality assessment will drive whether your obsolescence strategy will be proactive or reactive.
Yeah, it's normally quite often used also to provide priorities in investment in obsolescence management. So obviously, if it affects fight, move, and float for a warship, it's highly critical. If it just affects, being alongside and filling up, then it's less critical. That's perhaps not a very good example, but
okay. I want to talk about something that we've not covered going into the final sort of part of this podcast is obsolescence management planning in design. So before we've talked about a lot about in manufacturing assembly, we've not really talked about design. So what are the major elements of where it impacts in the design stage of a product, an item, a tank, a machine in industry?
So in my view, I'll talk at the moment. David, you can have your view after my view. So in my view, obsolescence should start right at the beginning, of the concept phase of the item of the product. And things that you can look at are things like preferred parts lists. So when you come to choose your components, you know that you've got longevity in those various technologies that will allow you to have that longevity and support.
Yeah, effectively, one of the things we have to be really cognizant of is that when we start to design a product, we probably at the design stage have committed to probably 60 to 80% of the material costs. So therefore, it's so important that at that stage, and one of the most fundamental ways of stopping short or medium-term obsolescence is to ensure that when we design something, we design with good strategies, looking at the technology, especially if it's electronics, looking at roadmaps of semiconductors, memory devices, to make sure there's a good roadmap going forward, bearing in mind obsolescence occurs across every type of item, but also is more prevalent in the long sustainment programs. So therefore, when we go into the design phase and even in the concept phase, we start to look at using well-known and well-respected roadmap products that we build into our design. Most companies these days, I'm pleased to say, tend to have what we could call a preferred parts list or a preferred items list or common components database, especially when we're talking electronics. And those companies that are designing something, especially with a long design period, should choose from those particular items lists. And I'm pleased to see that most companies do that now. This protects the short to medium term period of design into manufacture. I have worked on programs and experience of programs where it's been a fairly long design period, and by the time it's got into manufacture, it's been 50% obsolescence. So having a good preferred parts list, components management plan, and there are some standards around, especially for the aviation and electronics worlds, to conform to those sort of company policies and plans. And then if you want to move outside of that for some sort of other type of item, you get approval from your organization to add it to the parts list. So you're controlling very much the items that go into your initial design. Now, the next stage is to make sure that an obsolescence risk assessment is available at the first design review. So most companies have design reviews. So when you go through your design review with whatever criteria you have into your design reviews and contribution to the design review, you have an obsolescence risk assessment. And that risk assessment should look at least the minimum length of your contract. So you're protecting as best you possibly can the use of items that will not go obsolete or minimal chance of going obsolete in the near term. Next, you have to be cognizant of what's going on in the legislation world and understand, is there going to be an impact from something like REACH, future dates of substances of very high concern going onto their register. So you need to also consider those sort of aspects. Then the next thing you have to do, if you've got software involved in your program, you have to make sure that there's a good roadmap for the software you're choosing. So you're choosing software that has a roadmap, again, that provides longevity to your program. And thirdly, if you're using field programmable gate arrays, make sure you always use gate arrays that can be multi-programmed. Some gate arrays can only be programmed once. So therefore, if you want to upgrade it, you've got to replace the gate array. So make sure you're using field programmable gate arrays that can be multi-use. So that is very much in the early design phase. Then making sure that your design tools, and this is it could be the schematics that capture your board designs, it could be your overall product engineering tools, they actually link to the obsolescence management world. So therefore, any component you choose on your design, it goes into your items list, which most companies control through a product lifecycle management system. They actually link to the obsolescence, and you choose items that are going into design that have got a good life. And this is where, again, having the integration of obsolescence management tools into the design world and into lifecycle management forms a complete picture at the design phase. IEC 62402 2019 does have a number of strategies that you should look at when you're designing. This is modularization, transparency, and so forth. There is a list in 2019 that they say is good design practices.
One of the sayings within defence world is design the support and support the design. So ensuring that when you are designing a product, that product is supportable through its life and maybe beyond that. And so understanding everything that David's just alluded to there is paramount.
We did this quite late on in the podcast, but I believe from listening to you guys that this is probably the most important section of managing obsolescence properly at the design stage, because if you get it wrong here, then it causes problems downstream, doesn't it, further on?
It does. So we have a whole range of case studies of equipment going into production, going into service support, and of being obsolete, with items obsolete before they even actually go into service. I can quote you one without naming the program, but there's a program I think it's now 5 to 6 years before it actually goes into delivery, has already got significant obsolescence in because of the longevity of the design period that it takes. So, yeah, it has a big impact on long-term programs. Shorter-term programs, perhaps not so. We have a big impact, of course, on supply. That most of the electronics are governed. If you look at the semiconductor world now, the aerospace and defense, if you come from that world, is less than 0.1% of the semiconductor market. All of the semiconductors go to commercial programs. So again, it's so important to choose the right family of components at the very beginning in terms of aerospace and defense. And the same applies to the oil and gas industry, subsea oil and gas. We've done work with them. They have exactly the same problems as the defense industry, as does the automotive, the rail industry, cruise ships. They all have exactly the same problem. We've even worked on a program with a pharmaceutical company to identify obsolescence on their production lines. So it's not just aerospace and defence; it is a whole industry. And of course, one of the big tests we're going to get is when we start really doing high scale electric car manufacture. That's going to have an impact on availability in other markets as well.
So one of the key issues with the later you leave, if you don't manage obsolescence through life, is the opportunities and the of resolution become diminished, and can become quite costly, because you end up probably driving for either a minor or a major redesign, and we've seen that with Challenger 2 tank that didn't have any upgrades for about 19 years. Or so, and so you end up with a capability that's not what it was designed for.
I think if Tim's right, if you look at the cost curve for obsolescence management, it starts very low, and over a period of time, it exponentially increases. And the role of the obsolescence management manager is actually to keep that cost curve as far to the left of the curve as you possibly can.